All right, welcome back, Algebra 2. Here we go, guys. We are now in section 3 of chapter 5. All right, we are solving quadratics with graphing, which, by the way, I'm going to teach you how to do the graphing part in class using the calculator. All right, just to make sure that I can get everybody on the same page and everybody understands exactly, the series of buttons that you have to push and when to push them and all that info. It'd be a lot easier to do that face-to-face, so pay close attention in class. After you watch this video, that would be the next day. But the factoring part, we're going to do that in this video. Okay, factoring also is something that you've already done. All right, you do that in Algebra 1. You may do even a little bit of it in geometry, but it's a bit review. All right, so that's good. So right here, this next note, they're going to talk about connections, basically the roots of an equation, or the zeros of a function, or the solution of a quadratic. All of those phrases mean the same thing. Okay, so that last little sentence, don't be confused. If they change the phrasing and they're saying, oh, what are the roots? That just means solve it. All right, find the zeros or find the full solution of the quadratic. Sometimes it depends on the method that you use. They may then change the phrasing. Like if you're graphing it, they're going to say the roots. If you're using the quadratic formula, which we will be using later on, they may say the solution. They may say zeros if you're doing the factoring method. Okay, so it kind of just depends, but really it's all the same thing. All right, then some more terms that I want to make sure you know. If you have two terms in a polynomial, like if you had 3x minus 5, there's two terms there. That specifically is called a binomial, bi for two, nomial, it's like the number function. If you have three terms, it's called a trinomial. So tri, that's three. And then kind of the umbrella all-encompassing statement is they are all polynomials, like many numbers or multiple numbers all put together to create a function. Okay. And then as it says right there, I'm going to show you an example in class on how to do the calculator method with this. All right, but let's just say that first one, we're going to do that one in class. So the next one that we're going to jump into, number 2, actually, is a review of factoring. Okay, so let's do that right now. You'll remember this is a trinomial, and we will immediately jump into doing double sets of parentheses. And what we're trying to do here is create two binomials. All right, and the first thing that you're going to focus on is this first term right here. All right, so notice that there's no coefficient. That's great. That's really helpful. And all you're dealing with is x squared. So that means you're going to break this down right here and right here. There's an x, there's another x, because x times x is x squared. You're kind of doing the opposite steps to this. All right, so that would be step 1. Now step 2 that we're going to be looking at here is this sign right here, a minus sign. How do we get a negative when you are multiplying? And the way you do that is you need opposite signs, right? A positive times a negative would equal a negative. So that's how you get that sign right there. Now, step 3 is we look at this number, 6. And we have factors of 6, 2 and 3, or 1 and 6. Now, weirdly enough, both of these factors, if you use arithmetic through addition or subtraction, depending on what you use, could create 5. So I'm going to underline the 5 right there, because those factors are what you use to create 5. Now, focus back on what the signs are. It's a positive and a negative. If I do 2 and 3, that's going to basically be saying 2 minus 3 or 3 minus 2, which cannot create 5. But 1 and 6, through subtraction, can create 5. Now we just need to figure out which order is it. Is it a positive one or a negative one? And at that point, then you need to focus on that sign right there in front of the 5. We want to create a negative 5. So we got to put a negative 6 and a positive 1. Okay, so that's what we're looking at when we factor it. But what they are asking us to do, let's see, is we're trying to calculate our final solution. So you have it factored, but you technically don't have your actual solutions yet. So how do you do that? What you do is you solve each of these binomials, okay? So I'm doing this one very extensive. I realize some of you probably have already figured it out, but I'm just going to show you every little step here. Think of it as x plus 1 equals 0. That means that x equals -1. Then think of this as x minus 6 equals 0. That means x equals 6. So those are the actual solutions, -1 and +6. All right, let's now take a look at example problem number 3. All right, this is a little different. It's a binomial, not a trinomial, and each of these terms shares a value. What value do they share? X, meaning they're actually sharing the variable x. So factor an x out. Take it out of both of these terms and then rewrite what you have. You have x minus 8. If this is what you're left with, you can't go any further, okay? And if you remember what we literally just did, we set both of these things equal to 0. Remember the x plus 1 equals 0, x minus 6 equals 0. Do the same thing down here, and you basically set yourself up with one. One of them is just x equals 0. That's what that one is. Okay, this one over here would be the x minus 8 equals 0, meaning x equals 8. You'll kind of figure out basically it's just the opposite of the sign that's in there. So we are done with example 3. X is 0, x is 8. All right, and you'll remember that a parabola, remember that makes a U shape. So it's not uncommon to have two answers. All right. I'm not saying that there aren't problems where you'll have one answer, because sometimes there are, but it's not uncommon for a lot of these to just have two answers. All right, let's move into example 4. Solve it, find the roots. Basically, that's saying the same thing twice, right? Find the roots, solve it. That's the same thing. So step 1, though, is we want to take that -4 and move it over. We want to create the trinomial. So now we're actually looking at x squared minus 4x plus 4. So now we have a trinomial. That means we probably could factor it. So break it down into double parentheses. Look at where a is. A is in front of x squared. It's just a coefficient of 1. We like coefficient of 1s because that means we could just break the x up right there and right there. Now the next step is to focus on this guy. If that is a plus sign, then you look at what the sign is right there. That is a negative sign, and in the parentheses, you will have double minus signs. Okay, so this is the process you go through. Look at the second sign. Is it a positive? Yes. Now look back at the first sign, because what that is what goes into both of the parentheses. Boom, minus, minus. Okay, now if they're the same sign, minus, minus, that means you're using addition to calculate this middle number right here. So that means what are the factors of 4 that if I add them together would recreate 4? In other words, what are factors of 4? 2 and 2. What's 2 plus 2? Still 4. So that is what I put right here. Now what you should see is you have identical binomials, x minus 2, x minus 2. If that's what you're dealing with, you will actually only have one solution. And what is that solution? Both of these guys will equal 2. So x equals 2. Only one solution because the binomials are the same. All right. Let's do another one of these. All right, find the roots. Now this looks very different, and I'm going to show you a little bit more of a streamline method specific to a problem that looks like this. Okay, so how would we do this? Let's actually start by dividing both sides by 25 to isolate the x squared and get a 9 over 25. Here's why. Because how do I get rid of a squared? What's the opposite of that? The opposite of that is square root. And what you do to one side, you got to do to the other. So that square root eliminates the square. isolating x, getting it totally by itself. And why do we like 9 and 25? Because both of them are perfect roots. Square root of 9, 3. Square root of 25, 5. Boom. That one is done right there. But one little extra piece that you might want to pay attention to is we probably need to put plus minus. Because if we square a negative, we still get a positive. If we square a positive, it stays a positive. So that plus minus should probably be put right in front of that fraction. Last one, guys. Last one. Stay with me. Here we go. Let's finish strong. We need to write a quadratic function. So we're going to go backwards. We already know the answers. It's telling us we have zeros at 5 and negative 5. So let's think back real quick. Let's go to the top. How did we get those solutions of negative 1 and 6? Look back at those parentheses. All right, if I wanted 6, I had to say x minus 6. If I wanted a negative 1, I actually had to say x plus 1. So now using that logic, if we go back to here, what I'm saying is if I want a positive 5, I'm going to need to have parentheses that actually say x minus 5. And if I want a negative 5, I'm going to need parentheses that actually say x plus 5. But I'm not done yet because I actually didn't create a quadratic yet. I just created two binomials. So how do you go backwards from binomials then back to a quadratic? You have to FOIL. Ah, yes, that would be the first times the first times the second. Let's do that. X times x is x squared. X times negative 5 is a negative 5x. Now let's do the next one. 5 times x and 5 times negative 5. 5 times x now makes a positive 5x. 5 times negative 5 makes negative 25. We're actually not done yet. Why? Because negative 5x, positive 5x cross each other out. So let's simplify that down to our final answer, which is x squared minus 25. That, my friends, is the quadratic that would give you the zeros 5 and negative 5. All right, that's all I got for you guys. I will see you in the next video. All right.